All right, this is the last bit of this topic. So simplifying something of the form a cos x plus b sine x. And so in your textbook there's a proof of this in there. So if you have a cos x plus b sine x, it equals r cos x plus alpha, where r you get from your a and your b, it's a squared plus b squared. And for your alpha, cos alpha is a over r, and sine alpha is b over r. All right, and alternatively, so that's addition formula, right? Okay. So this is related to addition formula, and of course you could do a sine one as well. All right. And so a cos x plus b sine x is r sine x plus beta, and r of course is a squared plus b squared. And the sine of beta is a over r, and the cos of beta is b over r. All right. So let's have a look and see how we can use these things. So something like this. Express cos x minus root 3 sine x in the form r cos x minus alpha. All right. So we are looking at a cos x plus b sine x being cos x minus alpha. Now, if we have a look at that, what we've got here is 1 cos x plus negative root 3 sine x is what we've got. Okay, so a is equal to 1 and b is equal to negative root 3. So for our r, oops, got ahead of myself, r is the square root of 1 squared plus negative root 3 squared, which is the square root of 1 plus 3, which is square root of 4, which is 2. Right, now, cos alpha, when we go back up here, cos alpha, there it is, a over r. So cos alpha is 1 over 2, and sine of alpha is equal to b over r, so negative root 3 over 2. Now, here, this is positive half, so we're in the first or fourth quadrants. But here the sign is negative value, so we're in the third or the fourth quadrants. All right. Now, what we need to do is we need to have these things marrying up. So because alpha, the angle, it's going to be in the same quadrant for these. So here we've got fourth quadrant. So alpha is in the fourth quadrant. All right, and cos minus 1 over half is equal to pi on 3, and it's in the fourth quadrant. All right, and so if it's in the fourth quadrant and pi on 3, for the purposes of this stuff here, we would go the closest way. So we're not going all the way around here. Well, you could, but we want to go the shortest way. And so what we're doing is therefore then alpha would be negative pi on 3. All right, so negative pi on 3. And so from that, this thing here, up here, which is therefore cos x minus let's get rid of a few of those things and redo it. So cos x minus root 3 sine x equals r, which is 2, cos x minus alpha, so minus negative pi on 3, is 2 cos x plus pi on 3. All right, so we've done that. Now let's just go back. Hence, find the range of this. All right, so here we've got 2 cos x plus pi on 3. And so remember that the biggest that cos of anything can be is equal to 1. And the smallest that cos of anything can be is minus 1. So here for the range, we're looking at the highest to the lowest, and of course that has to do with our amplitude as well. So there's a couple of different angles that you can look at this. So the max of cos of that stuff is equal to 1. The min of cos x plus that stuff is equal to negative 1. And so fx might be 2 times 1, which is 2, or fx 2 times negative 1, which is negative 2. Whoa, that's an interesting one. Negative 2. Oops, let's get rid of that. Negative 2. And so the range, what we ask for, because we're not worried about what it's doing in between, we're just its maximum and its minimum values, and for sine and cos, both ends are included. So there we go, from negative 2 to 2 for our range. All right, so you could also look at it at a graph, so it's not translated up, so it can go up 2, down 2, you get to the same result. Anyway, I'm starting to waffle. Let's not waffle. All right, this next one. Okay, so interesting. Cos x minus root 3 sine x is equal to 1. So now we've got an equation that we've got to solve. Now, this is a bit complicated in terms of there's nothing else that we've done in the past where we can combine all of those things together, except for this, what we've just done. Now, this first part, the cos x minus root 3 sine x, we actually simplified that in the previous part up here. Right, that's what we had there. And we ended up with, where are we? There it is, here, this one. Right, we ended up with that. So that's 2 times the cos of x plus pi on 3. And so that is equal to 2 times the cos of x plus pi on 3. All right, so if cos x minus root 3 sine x simplifies to 2 cos x plus pi on 3, and cos x minus root 3 sine x is equal to 1, so that means that 2 times cos x plus pi on 3 must also equal to 1. All right. Divide by 2 both sides, so cos x plus pi on 3 is equal to 1/2. All right, 1/2, positive number, cos it's positive there and there. Cos minus 1/2 is pi on 3, so they're a reference angle, that's pi on 3, that's pi on 3. All right. So next, sorry, I'm being vague here. All right, so next, so notice that this here and this here are different. Now I'm going to show you another way for something like this, something that's simple that we can do with this pi on x plus pi on 3 rather than changing the range of this now. So this is another technique. I haven't actually done this one before, but you can say, all right, let's not worry about all of that. It works okay for something simple. So we're looking for x plus pi on 3. All right, and I'll say, all right, so what if we went that way? So then it'd be negative pi on 3. All right. But if we're going this way, well, we could go around there, pi on 3. We could go all the way around to there, which is 2 pi minus pi on 3. We can go around there, 2 pi plus that pi on 3. Like so, and get that. And so what I've done then is, like, I've gone a bit further than just 0 to 2 pi, right? So I've gone a bit further each way, and then I'm going to eliminate anything that doesn't fit in later. So with this here, now I need to subtract pi on 3 from everything. Comma, 2 pi minus pi on 3 minus another pi on 3, and 2 pi plus pi on 3 minus pi on 3. All right, that's negative 2 pi on 3. This one here is 0. 2 pi minus pi on 3 minus another pi on 3. So that's minus 2 pi's on 3. So in 2 pi there's 6. 6 minus 2 is 4 pi's on 3. 2 pi, plus minus, so that's 2 pi. All right, so now we have a look and we go, okay, so the x domain for x went from 0 to 2 pi. This first one's not in the domain we're after, so eliminate that. And 0, 4 pi on 3, 2 pi. And so there's our answers. All right, so that's another strategy, another technique that you can use if you go a bit further. It can be a bit tricky sometimes, so often it's best to adjust that before you do it. All right, so there's that example. And our last example that we are going to do is this one. So now you'll notice here we've got 2x, 2x, 2x. But from what we had is that we had a cos x plus b sine x equals r sine x plus alpha. All right, so the textbook does a different method to what I'm going to do. But what I'm going to do is I can say, okay, this x that's here, and this one that's here, and this one that's here, if I replace that with 2x, all right, so if I replace that with 2x, so I'm working with a cos 2x plus b sine 2x equals r sine 2x plus alpha. And I'm going to work with that. All right, so if I work with that, and I look with what I've got at the top here, then what I've got at the top here is I've got then that a is root 3. Hang on, what have we got? No, sorry, not a. Again, they've swapped this around on us, haven't they? So a is not. So a is the one in front of the cos. So a in front of the cos. What's in front of the cos? A negative here. The negative how many? Negative 1. So a is negative 1. And b is the one in front of the sine, which is root 3. And r, of course, is the square root of the square of those, which of course is 1 plus 3, which is 4, which is root 4, which is 2. All right, then when we go back to our thing there, sine of beta, well, beta alpha, all right, so sine of alpha, in the thing that I used way back here, I used beta, this one here, so I used beta. All right, but in this example there, using alpha instead of beta. So here we come down. So alpha. So the sine of alpha is a on r, which is negative 1/2. And the cos of beta, or alpha, as it's using in this particular one, is b on r, which is root 3 on 2. All right, so negative for sine, third and fourth quadrants. Cos is positive in the first and fourth. So the common quadrant is the fourth quadrant. So our angle that we are looking at then is down here, this one here in the fourth quadrant. And remember, we'll just go the closest way to it, so we'll go down that way. So sine minus 1, let's go of 1/2. And when you look at your triangles, that would be pi on 6. So our alpha then, so this here, reference angle is pi on 6, we're going in the negative direction, so negative pi on 6. So, therefore, root 3 sine 2x minus cos 2x will be equal to r, which is 2 sine 2x minus pi on 6. Let's just check there, but it's plus here, right? It's plus there. Plus and a minus is a minus. So minus pi on 6. All right. So there's another thing that we can use to manipulate and rearrange to help us find some answers in some trigonometric equations. All right, so if there's anything you need clarifying in there, make sure you get assistance, and as always, have fun.